Hello everyone, welcome back to another new guide series, and in this one we are going to take a look at the vectors in Nuke. So what I want to tell you about the vectors, how vectors works in Nuke and how we are using vectors in Nuke in general, and what is the vector basically and how we can manipulate vectors to use in our advantage. And there are many things in vectors, so we will see all those examples as you can see in this script. These are all the examples we are going to see, but first of all we will see what is the vectors and the tools which we have in Nuke to generate vectors and to use vectors in our compositing task. So we will see all those things and we will understand the vectors, so we can experiment with vectors while compositing, and we can understand better vectors in general. So let's get started. Okay, so what is the vector first of all, then we can understand step by step easily. As you can see here, in compositing, vectors is a mathematical tools used in represent position, movement, direction and transformation of element within a digital environment. They include position, xyz, velocity, rotation, scaling, directional and normal vectors, crucial for creating realistic effects and controlling visual element in compositing software. So basically whatever like if you get any CG, that vector is generated in this digital environment, and it also have the x and y position and all those vectors and all those scaling, direction, all those things. So in a simple word, vectors is storing this velocity, rotation and position, all those information in a number form. So in every frame is basically storing all these information based on the what vectors you are generating. So in Nuke we only have x and y, we don't have a z. So for the z, it should be coming from 3D software, okay, from a 3D environment. So in Nuke we can only generate x and y. Using these x and y we can manipulate in z also. So let's see this. So this is the vector direction which I made. If I view it here and if I go to the first frame, so you can see, so basically in Nuke we have this vector. Like if you consider the red is telling the vector direction, I mean the position or scaling or whatever in every frame, how is moving, how is behaving in left and right, it's indicating in red, and what is going up and down is indicating in green color. So only two channels we need, red and green, to generate a vector in Nuke. Alright, so let's see this above one. So like position vector, so let's see this short example. Position vector, this represent the location of object in 3D space. It include three component x and y and z coordinate. The position you all know is the position path which we get from the 3D department, so it's also called vectors, and it include x and y, z. And let's see the velocity, so like motion vector we also say. So this include the speed and the direction of a movement of object. It helps to create a realistic motion effect like motion blur. So obviously it's just for motion blur thing, so it's storing every pixel position in a vector form, so we can apply the motion blur. And let's see the second one, the transform vectors. Transform vectors impose the rotation, scaling and translation information. And also we have this rotation vectors is describe the angular orientation of object. Scaling vectors determine its size, proportional, and translation vectors is represent its movement displacement. So basically we can use like this is also like transform which include all these scaling, rotation and transformation we can store in a vector form. So this is also coming from 3D package. And the normal vector, so it's just a normal path what we get. And see the normal vector used in shading and lighting calculation to determine the direction a surface is facing. It's crucial for realistic lighting effect. So like we have a 3D we are getting passes from normal and all those things, we can use this one. So this is just a normal pass, it's also a vector, so that's why. So as I said, so the vector is basically we have information stored in x and y position in every pixel of the certain object, and we can use that vector pass to add motion blur and also add transformation and also do a lot of things in Nuke. So we will going to see everything in this tutorial. So let's first see the vector generator nodes we have in Nuke. So as you can see, we have many tools here. There are many, I guess, but these are the most common one we are using compositing tasks daily. So let's see one by one. So this is the motion blur 2D, motion blur 3D, obviously the smart vectors and vector generator, the motion blur, the lens distortion also, and the scan line. And this is just a ST map with the expression, so red and green again. So and vector reader, so these are, we can generate a vector here, and these tools can use the vectors to perform a certain action. The grid warp, the vector blur, the eye distort, and vector to motion, the chronos for retime, overflow, and the ST map. So these are the nodes here, and let's see the one by one how we can use this one. So first of all, let's see the position one. So obviously the position one, position and normal. So I have two examples here. So this is just a basic animation I did here, so you can understand. So you can see the movement is very fast, and it's I think only 50 frames. So what we can do in the scan line render, we can go to the shading tab and we can output vectors. You can see here we have a tab, so I output a vector, P for position and N for normal. So I made a channel here, and if I go here, you can see we have this this normal, all three directions. See that we also get red, green, and blue also. And in the normal, if I view it here, we also get red and green and blue, all three direction. But they both are storing a different information. Like for the vector, we get surface normal direction where this is facing, so it's like facing like this and like that. And for the position, it's storing the information like this exact position in the 3D space. So because I animated the camera, the object is not changing. It basically, we can use a position mask, position pass to make a 3D mask. I have this AP mat here, so I view it here. You can see I have this this one. If I play, it will properly track because it's a position based. So it's no the 3D, it's no the object position. Because if I view it this scan line render, and if I go in a 3D space, you can see the object is not moving, the camera is moving, right? So that's why this thing is properly sticking to the surface, because it's no the object is not moving, and that information is stored in this position bus. And you can use using AP mat and many others tools to do a mask. And we can use this mask to color correction and all those things. And the same way we have this normal. So this is the normal I just extracted with using the shuffle one. And we have many tools, like we have this normal rotate in the Nukepedia, also the Nuke Server toolkit. So if I view it here, you get this angle. If I animate, see this is properly sticking because it's no the object is not moving, the camera is moving. So it's basically the angle. So if I open this one, you can change the angle how we want, and it will properly stick on that surface. And you can use this one to do relighting and all those things. So like if you have a 3D render, and if you have a normal path and position path, just like, so you can do many things in CG compositing. So this is the basic idea for this normal path and these things. If you view this, see the values here, and so it's basically red and green, blue. See the blue is here. These are the position and normal paths in a vector form, and this is the very basic way to use this normal path and position path. There are many advanced way, but I just want to cover the basic of vectors and explain the vectors in Nuke. So these are this position, normal path, and let's see this velocity and motion. Okay, this is very interesting because most of the time we are using vectors for adding a motion blur and all those things. So let's see this first example. I have this animation here. This is just a roto animating, and obviously we don't have any motion blur. So let's go this frame, and in this one you can see I'm using smart vector. Okay, I already cover in my motion blur guide. In that one I covered all those things, but here I'm just again refreshing and telling you the vector side. So in the smart vector, you can generate a smart vector, and you can use this node called vector to motion. So if I view it here, now it's basically converting my this thing, what you call smart vector, into motion. So if I go it here and if I play, you can see this is the vector. Basically we are converting the smart vector. It's already a vector, but we are converting this one at motion. So if I view it here, and I'm just copying the vector, I'm copying the motion into this B pipe, and then we are using this vector blur. So vector blur is, as I said, I covered this one also in that motion blur guide tutorial, so you can check that out. So if I view it here, and if you can see, now we are successfully added the motion blur on this one. So this is just a one way. All right, so we will see all the other way how we can add motion blur. So let's see the example number 2. Again the same ball, but this time we are using this motion blur 2D node. So this is also outputting the motion paths, I mean the vector paths. So if I view it here, if I on off, you can see the entire screen is blinking in a random color, and you can see we only have 2 color. We don't have like if I open this vector blur motion blur 2D, you can see it's only we only have 2 colors, red and green, U and V. All right, and to generate a vector you also need a 2D transform. Just like you can see, I added transform here. So what I did, basically I just animated this one based on the movement. You can see I basically traced this movement. So if you have a certain object in your frame and it's moving like this, so you can use this one to we just basically need a transformation, 2D translation here in the keyframes. So based on that, it will generate a vector, motion vector, and then we can use in this vector blur. So the same, if I compare this motion and this motion, you can see there are subtle changes, but they are almost same, changing the shape because they are using a different way to generate a vector. This one using a pure 2D values, and this one, the smart vector, is based on this movement of this object. So in every frame it's calculating the vector, and then we are using this one to add a motion blur. So now let's see the third one. So the third one, we have a node called vector generator. So it's a similar like this smart vector, but we don't have to do this conversion and this thing. We just need to just plug it here, and if you go here, we can see the motion, and if I play, you can see this is the motion we get for this object. And see like this, if I go this frame, if you sample, we have negative values on all those values here, but it's working fine because this vector blur, it's reading, it's he can read everything for the pass. So if I view it here, you can see we added a motion blur using this tool. See, it's very nice. All right, so let's see the next one. So the example number 4 is like we just add a motion blur, and because if I open this one, it's already generating vectors inside. So you can see we have this vector detail. If I hover over, see it's saying use this to adjust the density of the calculation motion vector seed. Higher detail pick up a finer movement, but will take longer to calculate. It's clearly said it's generating a vector inside, and then we are using vector to add a motion blur. And in this one we have this FG vector, and you can if you have a vector, you can connect here, but most of the time we are not using that. We just plugging and just cranking the samples and adding a proper shutter angle, and we get the motion blur like this. All right, so and example number 4. So this is like again the scan and render, and if I go here, go to the shader, we can add we can generate a motion vector here also. See this motion vector, I use the classic one and I assign this channel motion, and based on that we get this motion blur for this 3D object. See, so we get some artifact, I don't know, see here, you can see this some artifact here. So we can try this one also, or again here I'm using now I'm using this time this motion blur 3D. It's basically using your camera. Here we are using like 2D transform. Now for motion blur 3D, we are using the camera to generate a vector, and again using a vector blur. So this one is giving you different output because in this scene the camera is moving, object is not moving, right? I think this one is better for this kind of situation. Based on your shot, based on your situation, you have to choose which motion blur will work properly. So in this situation, the camera is moving, object is not moving, so I prefer using this motion blur 3D stuff here, using the camera on all those things. So you can see now we get very nice motion blur here, and we don't have any edge issues or anything like that before we have it, I think, this frame. So if I check this one here, yeah, see this one is much better. We get very nice fall off here also. So let's see the next one. So the next part is we can use vector to add distortion basically, right? So what we have here, we have a grid here, and I'm using this lens distortion. Okay, in this lens distortion, I'm not directly adding a lens distortion. You can see it's not affecting. Instead of I'm outputting the ST map option here. So if I do redistort, so it's basically adding a distortion like this one, you can see it, but I want ST map output. And if I view it here, so this is the ST map motion, you can see it, and then you can use this ST map node to add this lens distortion. This is also red and green, it's also have a blue, so generating this thing. But if in the ST map we can only use red and green, see only two channels you can use, and it's for adding this nice lens distortion. All right, so let's see the next one. And here to I'm using iDistort and this noise. So basically we have this, I'm just using red and green channel. Down you can see we have values here, and some values are going in negative. You can see this blue is going in negative. So that is the whole idea. And then I'm using this copy node again, using this A pipe red and green, because we only need two channels to make a vector pass. So I'm adding those two channels in the forward U and V, and using iDistort, distorting my image. So if I open this open iDistort, you can see it, assign it the motion channel, and it's only using red and green, and just cranking the values to whatever you want, you can do like this. All right, and again let's see this third example. Again I'm using ST map here, and for that I'm using this ST map generator what I have, and with noise I'm just multiplying this over to change the values here. So again I already covered these whole things in my tutorial, so I will put the link so you can check that out. So again this is also again a vector, you can consider this is also a vector pass, again using ST map to see stuff like this. So if I just down the multiply, you can see you can reduce the size, and you can basically do a distortion thing like this. And again here also I'm using the same setup, but using a ST map I'm using iDistort. See, I'm using iDistort and doing a channel, again adding a channel into forward U and V. Again iDistort, you get the similar, not the similar, but get the distortion effects, and you can change the values how you want, like that, and distorting your image, and you can do offset or all those things. All right, so again for this distortion I have a full video about Nuke distortion workflow, so you can check that out also. Now let's see this vector tracking. So everyone knows, but let's see, everyone knows how to do smart vector, all those things. So this is very simple example. Again we have this camera movement. Again I think in this is the motion we have, and what I want to do, I want to generate a vector. So this time I'm using smart vector, and I have this noise, so I want to stick noise on this surface. So what I will do, I will generate a vector, and I'm using this vector distort, so it can read the vector smart vector, and this is my source. And if I view it here and if I play, now you can see some like surface tracking, you can also say that. So it's look like a 3D, but it's not. It's basically reading the every frame and every pixel information, and then you can add this this vector tracking like this. And what I did, I just masked with the original alpha, and you can just over this one and match moving basically. So this is again the it's also using the vectors underneath. As I said, the name in the smart vector, it's using a vector to perform this action. We have some glitching here, but that's fine, so that can easily go. So if we just change some setting here, I guess it will, and I think it's gone now. See, so this is just little tweaking we have to do, but in general using vector to performing a match move. So this is very good for organic surface, because it's calculating the vector in every frame and every pixel basically, so we get very fine detail. So similarly example number 2, we're doing the same stuff, but using a grid walk tracker. So if I open the properties, and let me just quickly view it here and play, so you can see it's a little bit different, because we have a grid like this one. So if you are so this is the grid, this big square, so it's only calculating where this point is intersecting, this point, this point, this point, and this point, and based on the movement it's doing a match move. See, So this point is moving here, this point moving here. So the distance between these 2 points is this is exactly match moving here and here, but in between it's not properly match moving. So if I view it here again using this grid of tracker in the smart vector, we can do a match move. And the cool part about this grid of tracker is generate a keyframe. So what does that mean? You can just unplug this one and we can make this in a side. It will work because we have a keyframe, match move keyframes. See that? So this is the another example of using smart vector. Last I have this vector based retime. In Nuke we have only 2 nodes that are using vector to performing a retime action. So the first one is the Chronos. So if I view it here in the Chronos, go to global, see in the Chronos we can define all those things. Here we have vector same as the motion blur. We can define the vector detail and based on that it will. So I will show you what. So I slow down this animation speed. See here, this is the speed now we have. Now after applying the Chronos, I reduce the speed half. So as you can see, it's very slow and it's looking very nice. You don't have any jumping frame, all those things. So in the Chronos we are using this motion set the interpolation and algorithm. So they have this motion, and we have many things like blend and frames. So but the motion is very smooth, so that's why I always keep the motion. The same thing in the overflow, same setting we have in the overflow, and all those things are using GPU. So the set frame range and outputting vectors 1, all those things. And if you need, you can also add a motion blur here in the shutter. So you can do that also here. So basically the vectors are very useful in compositing as well as in general in a VFX world. So this video is just about clearing the basics of vectors, how vectors is working and how you can use vectors in many ways. There are many experiments you can do in vectors. So just like I show, you can use this STMap thing in iDistort, and you can use STMap here also, like what we did here. All those vectors are same, they are just performing the different action, but you can combine all those things together and you can do many things in vector form. So this is a very basic tutorial about explanation about vectors. So if you have any questions regarding vectors and anything related to the compositing, you can leave the comment below, and you can join my server also, link in the video description. I hope you understand something about the vectors, and I hope I clear some doubt about vectors and in general. So let me know, and we will see you in a very next one. Have a great day.